Welcome to our website predicting heart disease with the shimmering pythons. What we do, we create a website that attempts to predict people's chances of getting heart disease with some data we found most accurate. For example, PyPlots is a major one we use to determine factors like smoking, drinking, age, etc. To make sure you have the info to know what habits are good for your health. If you have done any of these bad habits displayed, please stop them. They are horrible for your health. Why we do it. We are doing this not only to see how far Python, the coding language, can go, but if used correctly, can save lives and help give you info so you can protect yourself from having a large risk of heart disease. How we help. Using data and AI machine learning, we can calculate and determine your chances of getting heart disease. This can also bring awareness to people which heart disorders run in their families. Make sure they go to check it with a cardiologist to see if they need treatment. To make sure they can get help as soon as possible to help with this horrible disease. It has killed more than 800,000 people in the United States. People in the US die from cardiovascular disease each year. 160,000 of them occur in people under the age of 65.
Data processing, steps taken before we begin working with our data. Data from our data frame is discarded and cleansed during data preparation, leaving us with a clean, usable data frame. This is crucial for machine learning since it will lessen the likelihood that certain artifacts and errors will appear on the website. Data preprocessing is a data mining technique used to return the raw data into a format that is both practical and effective. Our data preprocessing involved binarizing and yes-no features, originally encoding features with an inherent order. One hot encoding nominal features due to prevalence of heart disease less than 10%. Our dataset consisted of only approximately 28,000 instances of individuals with heart disease and nearly 300,000 instances of individuals without. Our initial models were achieving good accuracy around 90%, but nearly predicting all individuals who don't have heart disease. Therefore, we use random undersampling to level our dataset. Random undersampling involves deleting instances of majority class.
Okay. This data shows like all this shows all the diagnoses for multiple people who took the test to find out if they have heart disease or not. And this histogram shows the general health of the best predictor for heart disease with around a 0.25 correlation. Right? However, none of the features alone are very strong predictors for heart disease. This one we made a pie chart about smokers who have heart disease and smokers who don't have heart disease. But in this pie chart only shows that 39.6% of the individuals without heart disease are smokers, while 58.6% of the heart disease patients are smokers. Also, age have a correlation with heart disease too. But in this pie chart, we can see that, you can see that the proportion of individuals with heart disease gradually increases with age. So as you can see, the people who are pretty young, like under the age of 50, a lot those people don't really have like heart disease. But as you get older, their chances of getting heart disease greatly increase.
Heat map for suspects of heart disease. These suspects for heart disease are smoking, heavy drinking, obesity, kidney failure, and sleep time, with many others. If you suffer from these factors, try to eliminate the one you have more frequently. Body mass cause for heart disease. We would think that obesity is a leading cause for heart disease because your body has gotten weaker due to the damage of overly high sugar drinks and greasy, unhealthy food. The wise decision is to beware your calorie and fat intake. However, we see here that the BMI distribution is pretty similar across those with and without heart disease. Drinking is no big problem for heart disease. Surprisingly, we see that drinking is not a large factor in determining whether someone has heart disease. A smaller proportion of those with heart disease are drinkers when compared to non-heart disease individuals. The reason why drinking is a big problem is because it only affects you harder depending on the time and how much is drank.
So machine learning. Our team implemented 3 machine learning models to predict whether an individual has or is at risk of heart disease. Random forest, support vector machine, and neural networks are briefly described along with the report of the model's accuracy. Our first machine learning model was random forest. The supervised learning method known as the random forest is a component of machine learning. It is employed to ensure that there's neither a high bias nor a high variance in the data within a training set. A random forest is designed to address a problem that no single decision tree can be trusted. A decision tree is a straightforward supervised learning technique that has 3 components: a root node, a predictor, and a leaf node. It can be used for regression or classification. This is just an example, and here's our confusion matrix. Our accuracy was 75.12% for random forest.
All right. For this is going to be about SVM, which stands for support vector machine. Both classification and regression are performed using supervised machine learning techniques known as support vector machines, or SVM. The most relevant phase is categorization, even though we also mentioned worries about regression. However, classification issues are where it's mostly frequently utilized. When using the SVM algorithm, each data point is represented as a point in the n-dimensional space. Of course, if you didn't know, this is where the n is the number of features you have, and with each feature value being the value of a certain coordinate.
Our last machine learning model was neural network. An efficient illustration of how any AI works is a neural network. It functions by simulating a massive number of interconnected processing units that resemble abstract network representations. The processing units are made up of layers of arrangement. The low-level code is abstracted when utilizing a neural network in Python, and tools like Keras and TensorFlow make it simpler to build neural networks. Here's a confusion matrix, and our accuracy was 75.04%.
Conclusion, all of our machine models performed similarly around 75% accuracy after a dataset was truncated through random undersampling. After random undersampling, we used accuracy as our evaluation metric, as our dataset then contained equal instances of individuals with and without heart disease. Such a project may be useful to a hospital or medical company so that they can pinpoint the leading factors for heart disease and to hopefully modernize healthcare. Because coding is the future in 10 to 30 years from now, doctors are going to be obsolete compared to robots or machines that are able to do surgery, give medicine, or discover diseases like heart disease by using a database of information on certain factors that contribute to heart disease.
Here's our team. Super proud of them. Amazing work these last 3 weeks.